Okay, guys, we're going to take a look at the isosceles right here, possibly just, I don't know, shortcuts, but just way to maneuver around and hopefully get to the point where we can deal with these. It's kind of like they're your times tables. Anyway, to start with, the ratio of the sides is 1 to 1 to radical 2. So we're going to talk about how to use those numbers to maneuver around or to find different side lengths depending on what's given in any particular problem. So to start with here, I'm going to take a look at a first example. I'm going to give you this side length here of the leg is 5. Well, since the legs are in the ratio of 1 to 1, that means, well, I multiply or divide by 1, it really wouldn't matter, and this side length is just 5. So yeah, the legs are just the same. We know isosceles, they're equal. Well, the key number between the leg and the hypotenuse is this radical 2. And since it is getting bigger, I'm going from a leg, going to a larger side of the hypotenuse, that means you're going to multiply your leg of 5 times the radical 2, giving me 5 radical 2. That's pretty straightforward. Most people do very well with that. So let's take a look at what happens when we get the hypotenuse. All right, well, in this case, if I've got the hypotenuse and the hypotenuse is radical 6, what would I do to get the length of the leg? Well, I'd have to take that radical 6, and since I'm going from hypotenuse to leg, it's getting smaller. And when it gets smaller, I'm not going to multiply, I'm going to divide. So I would divide by radical 2, that key number between the leg and hypotenuse, and I would end up getting an answer of radical 3. And both legs are the same, so this one here would also be radical 3. That wasn't too bad. So let's take a look now. Maybe what if we have hypotenuse, and the length of the hypotenuse this time isn't a radical? What if it's just 5? Well, once again, to go from the leg to the hypotenuse, it's getting smaller. The key number is still this radical 2. I'm going to divide by radical 2. So if I do a little chicken scratch off to the side here, I'd say 5 divide radical 2. But then back in your algebra days, you would have talked to, we need to rationalize this denominator. To rationalize, we got to get rid of that radical. And when I do that, on top, I'm left with 5 radical 2 over 2. And both of these legs would be that same value of 5 radical 2 over 2. All right, well, let's develop that a little bit further. Let's take a look at another triangle. Let's look at the hypotenuse again. This time, let's say that the hypotenuse is going to be a length of 7. And if the hypotenuse is a length of 7, going through this process of rationalizing, I would divide by radical 2, because once again, keep in mind, I'm going from leg or from hypotenuse to leg. Getting smaller, I divide radical 2. Divide radical 2, that means we're going to rationalize our denominator. And in the end, I end up with 7 radical 2 over 2. If I continue to do problem after problem here, we would see that a pattern is going to develop. And it's already started to. As I'm dividing by radical 2 in these last 2 examples, each time in the end, really, my answer ends up just being simply the hypotenuse times radical 2 over 2. Oh, there we go. It came up. And likewise, I divided by radical 2, and I just ended up with the hypotenuse times 7 radical 2 over 2. So what's the deal here? We could simplify this idea and say that when we divide by radical 2, that's the same as multiplying by radical 2 over 2. Well, that's not a hard thing to think of, because even back in your younger years, you'd have talked about dividing by 2 is the same thing as multiplying by 1/2. So dividing by 2, multiplying by 1/2, multiplying by the reciprocal. So that idea isn't foreign, that you could divide by something and have something else in turn you'd multiply by and have the same result. So that being said, that makes our life a lot easier here. So if I start looking at these isosceles rights and we need the length of a leg and I've got the hypotenuse, well, let's take a look. What if this is 9 this time? Well, 9 I'm going to divide by radical 2. But oh, dividing radical 2 is the same thing as multiplying by radical 2 over 2. So you end up with 9 radical 2 over 2 for both of your legs. Or maybe yet I've got another one, and this time I've got a hypotenuse. Let's make it a fraction this time. So fraction, we're going to make it 2/3. Well, 2/3, we're going to divide by radical 2. It would get a little bit messy if we're going to rationalize, because I would put the radical 2 in the denominator. I'd have to rationalize. But we said dividing by radical 2 is the same thing as radical 2 over 2. And I take this 2/3 and multiply it times that. So the 2 goes in the top, the 3 goes in the bottom. Those guys would cancel the 2's. And so I'm going to end up with an answer here of radical 2 over 3. So radical 2 over 3 for both of my legs. Now, keep in mind, guys, don't just be a robot and always say, oh, I'm going to divide, or divide radical 2 is always multiplying by radical 2 over 2. That would be silly, because think about what we're doing. For example, in this problem here, dividing by radical 2 is actually quite easy. So if you've got a number like radical 6 that easily divides by radical 2, go ahead and just do it. But if you don't, number like 5, that's not easily divided by radical 2. When you divide radical 2, you're going to multiply radical 2 over 2, and that's going to help you get your leg very quickly. So if I looked at a problem here, one last one, and I've got a number like, maybe let's make it an even number this time. So we're going to say that it's 6. Well, you divide by radical 2, which is the same thing as multiplying radical 2 over 2. So chicken scratch here, we got 6 radical 2 over 2. But since these numbers outside reduce, we do that. Your final answer for your leg would be 3 radical 2. Don't forget that you'd also want to reduce if it will reduce like it did in these last 2 examples. Anyway, hopefully, guys, that's helpful for you. And we will take a look also at the 30, 60, 90 here in a little bit.